All right, today we are diving into a ghost story, but not the kind you're thinking of. This one comes straight from the world of physics. It's a century-old mystery about the very nature of reality, and it all started because Albert Einstein just had a really bad feeling about something.
And this is it. This is the quote that kicks the whole thing off. Einstein famously called one of quantum mechanics' weirdest predictions spooky action at a distance. He just could not get on board with the idea that the universe would behave in such a strange, ghostly way. And that one phrase, spooky action, it perfectly sets up the entire puzzle we're about to solve.
So here's how we're going to break this all down. First, we'll look at what Einstein's spooky problem actually was. Then we'll jump into the huge debate it started. After that, things get interesting. We'll explore a third possibility, a totally different way of looking at the problem that goes beyond the idea of separation and introduces a two-level model of reality itself.
Okay, let's get right into it. Part 1. Einstein's spooky problem. And look, this wasn't some minor academic squabble for him. This was a battle for the very soul of physics, for what reality even means.
So what was this spooky idea that had Einstein so worked up? Well, it's a concept we now call entanglement. Imagine you have two particles that are linked in a special way. If you measure one of them here on Earth, its partner, even if it's clear across the galaxy, instantly knows and reacts. For Einstein, that was a huge no-no. It was like breaking the universal speed limit. Nothing, not even information, is supposed to travel faster than light.
And this all boils down to a core principle Einstein held dear. It's called locality. It's really just a common sense idea. For something to affect something else, it has to be nearby. You know, you push a box, it moves. A star's gravity pulls on the planets around it. There are no mysterious, faster-than-light connections across the universe. The universe, he insisted, had to be local, period.
And that fundamental disagreement, it set the stage for one of the greatest scientific showdowns of the 20th century. You had Einstein on one side, and pretty much all the other founders of quantum theory on the other.
So you basically had two teams. On Team Einstein, the argument was simple. This spooky action stuff is impossible, so quantum mechanics as a theory must be incomplete. It's missing something. But on the other side, you had physicists like Niels Bohr and later John Bell and Alain Aspect who kept running the experiments, and the results were undeniable. The data perfectly matched the strange predictions of quantum mechanics. Their conclusion? The universe isn't local. The spooky action is real.
So for decades, the world of physics was kind of stuck. It felt like you had to pick a side. Either the universe has these bizarre, ghostly connections, or our single best theory for how the subatomic world works is just plain wrong. And for a long time, it really seemed like Einstein's beautiful, orderly, local universe had to be thrown out.
But what if that was a false choice? What if there's a third way out? A possibility that suggests everyone, on both sides, was arguing about the wrong thing from the very beginning.
And this gets us to the heart of it. What if the spookiness isn't in the action at all? What if the problem lies in a much deeper assumption, an idea that both sides took for granted without even realizing it?
And here's the twist. The whole debate was framed as locality versus non-locality. But this new idea suggests that's the wrong fight. The real issue isn't locality, it's separability. It's a subtle shift in a word, but it makes all the difference.
So let's see how this one idea completely flips the script and gives us a brand new way to look at the cosmos. Part 4, Beyond Separation.
So what on earth is non-separability? It's the radical idea that at the deepest level, the universe isn't a collection of separate things at all. Those two particles from before, they were never truly separate to begin with. They are, and always have been, just two aspects of one single, underlying, indivisible reality.
And this is where it all starts to click. In this view, Einstein was right. There is no spooky action at a distance, because nothing is ever truly at a distance. The mistake that both sides made was just assuming that you could break the world down into separate, individual pieces in the first place.
Now, to really wrap our heads around this, there's one last concept we need. The idea that reality kind of operates on two different levels. The easiest way to think about it is like a real object and the shadow it casts.
This shows the two levels. Level 1 is the real deal, the deep, true nature of reality, a unified, seamless whole. No separate parts, no distinctions. Then there's level 2. That's our world. That's quantum mechanics. It's like a shadow that level 1 projects onto a wall. In that shadow world, things look separate, and the way they're connected seems mysterious, spooky even. But that spookiness is just an illusion, a trick of the projection.
So in other words, quantum mechanics is what we see when we take that unified geometric reality and project it onto a world where we insist on seeing separate things. The spookiness isn't in reality itself, it's just a byproduct of the way we're looking at it.
And the implications here are just massive. This level 1 reality isn't just a philosophical idea. On the tiniest scales, it could be the geometric origin of things like mass, and charge, and spin. And on the grandest scales, it's described by Einstein's very own equations for gravity. It might even explain mysteries like dark matter, not as some missing particles, but as huge geometric waves rippling through spacetime.
So the big takeaway is this: the ghost that haunted Einstein for decades might not have been a ghost at all. The spooky action wasn't an action. It was just the shadow play of a single, deeply interconnected reality that we were only seeing a small piece of. Einstein's gut feeling was right. The universe isn't spooky. It's just a whole lot more whole than we ever imagined.
And this leaves us with a final, pretty mind-bending thought. We experience the world as separate games. You know, me, you, the chair you're sitting in. But if, at the most fundamental level of reality, the universe is a single, non-separable whole, what does that actually mean for us?